Hello everyone, welcome to Welding Technocrat YouTube channel. Today we are going to learn about porosity in SMAW, its causes and remedies. Let us see the definition of porosity. The term porosity is used to describe gas pockets or voids in the weld material. These voids result from gas that forms when certain chemical reactions takes place during welding, or that is expelled from the liquid, but captured within the crystalline structure of the solidified weld. These discontinuities are usually round and contain gas rather than solids, and in this respect they differ from slag inclusion. The next is category of 5M for porosity in SMAW. Category 1 Manpower. Human factors: inadequate training and skill level, lack of attention to detail. Machine. Equipment factors: poorly maintained equipment, damaged electrode holders and cables. Material. Welding materials: contaminated base material, damp or low quality electrode. Method: welding procedures and techniques: insufficient pre-weld cleaning, incorrect parameter setting, unfavorable environmental conditions. And the last, measurement, inspection and testing, inadequate inspection methods, faulty testing equipments. Let's dive into the first category, manpower, its causes and preventions. Causes: inadequate training and skill level. Welders lacking proper training or experience may not handle the welding equipment correctly. We need to conduct comprehensive training programs, provide regular and thorough training sessions to ensure welders are skilled in SMAW technique. Lack of attention to detail. Carelessness or distractions during the welding process can lead to inconsistent techniques. We need essential supervision and monitoring. Implement a system of supervision to ensure that the welders remain focused and adhere to best practices. Category 2 Machines, its causes and preventions. Cause number 1: poorly maintained equipment. Faulty or improperly maintained welding machines can cause arc instability leading to porosity. We need to conduct regular maintenance, schedule regular maintenance checks and servicing of welding equipment and machines. Damaged electrode holders and cables. Worn out electrode holders or damaged cables can result in inconsistent welding current flow. Inspection and replacement. Regularly inspect electrode holders and cables for wear and damage. Replace as necessary. The third category, material, its causes and prevention. Contaminated base material, oil, rust or paint on the base material can introduce gas pockets causing porosity. Proper cleaning is required. Thoroughly clean the base material before welding to remove contaminants. Damp electrodes. Using damp electrodes can introduce moisture and contaminants. Use dry electrodes. Store electrodes properly to keep them dry. And the last cause, impure electrode. Impurities in the electrode can cause porosity. Inspect electrode. Ensure the electrodes are pure and free from contaminants. The next category, method. We will see the causes and preventions. Failing to clean the workpiece adequately before welding can lead to porosity. Implement strict cleaning protocols before welding. Unfavorable welding environmental conditions in the situation of windy and damp conditions can introduce moisture. Try to weld in a controlled environment. If outdoors, use windshields and maintain dryness. At the onset of making the weld, the weld is very vulnerable to porosity because the shielding has not fully evolved and the air at the weld site has not yet been totally expelled. Implement backwashing technique. It consists of initiating the arc a few electrode diameters ahead of the place where welding is to begin. The arc is then quickly moved back to the starting point where the welding proceeds in the normal manner. As the arc approaches the original initiation point, it melts any small globules of weld metal that may have remained in the weld pool. Too short an arc length will lead to erratic operation as the metal droplets short circuits during weld transfer, causing increased spatter. With some electrodes, shielding gases may not be generated and porosity will form. Use the proper amperage and arc length as recommended by the manufacturer. With long arc, the gas and the flux generated by the electrode covering are not as concentrated, so they may not effectively shield the arc and the weld metal. The dissipation of the shielding gases can result in porosity. So as a rule, the arc length should not exceed the diameter of the core wire of the electrode. The arc length is usually shorter than this value for electrodes with thick coverages, such as iron powder, in which drag electrodes are used. High travel speed will also make slag removal difficult, and the entrapped gas causing porosity in the weld metal is there. The welding travel speed should be adjusted so that the arc is slightly ahead to the welding pool. Incorrect parameter setting. Incorrect settings for voltage, current, and travel speed can destabilize the arc. We need to do parameter calibration. Use regularly calibrated and set welding parameters correctly according to the material and task. Gas evolution from priming paints, surface treatment. Organic paints will not survive the heat from the welding arc. Identify the risk of reaction before surface treatment is applied. If the paint cannot be removed, use cellulosic SMAW electrode. The last category, measurement. Cause number 1: inadequate inspection methods. Inefficient inspection methods may fail to detect porosity. Use advanced inspection techniques and reliable inspection methods such as ultrasonic testing and radiography. Faulty testing equipment. Uncalibrated or poorly maintained testing equipment can give inaccurate results. Regularly calibrate testing equipment to ensure accuracy. And the last measurement cause is poor documentation. Lack of proper record keeping can lead to recurring issues without traceability. Detailed record keeping. Maintain thorough documentation of welding processes and defects to identify patterns and prevent recurrence. Happy welding! Thank you for watching. Kindly like the video and subscribe to YouTube channel. Push the bell notification for new welding related videos. Share the video with welders, welding foremen, welding engineers and welding enthusiasts. Thank you once again.